By now, it's no secret that humanoid robots are having a moment. It's no wonder Goldman Sachs projects the humanoid market to reach $38 billion by 2035. After years of hype and promises, we're now seeing some incredible breakthroughs, and Agility Robotics is right at the center of it. Last year, Agility's robot Digit became the first humanoid robot to deliver productive work for customers like Amazon and GXO, a huge third-party logistics company. In fact, Digit was moving totes of Spanx women's wear products during the peak holiday shipping season. This year, Agility announced the launch of Agility Arc, a fleet management platform, and partnerships with Manhattan Associates and Zion Solutions Group. They also recently brought on veteran technology leader Peggy Johnson as CEO and promoted Melonee Wise to the expanded role of Chief Product Officer. We have both Peggy and Melonee here today to talk about what's next for Agility and Digit. We'll also be joined by Dr. Scott Walter, a two-time robotics company founder, in the second half of the interview. Welcome, Peggy and Melonee. Thank you both for joining me.
Thanks, Herbert. Thanks for having us.
So I have to say at the very beginning here that I'm incredibly excited for this interview because I honestly have been excited about you guys specifically. Several things that you guys do, I think, is very different than the other humanoid bot companies out there. First, you designed Digit specifically for being able to do useful work, and you thought of it from the ground up. You said, okay, what would it be needed to do the actual tasks, the various tasks that is designed to do? And then the second thing is you actually already have a RoboFab, which is a factory that you're about to build, and you've announced that. So, Peggy, thank you for joining us, and tell me more about what you think makes Digit different than the other companies, and your partnerships with Amazon and GXO.
Sure. Well, our robot is based on 2 decades of research combined with customer requirements. And we are the only humanoid robot that's deployed out in the field right now. So we're at customer sites, and that kind of interaction where we are in front of the customer in their facilities, understanding the environment that we have to work in those facilities is just invaluable for the set of data that it produces. And we believe that is the fastest way to general purpose robots. And all of our architecture decisions were based on following that path. And I believe at this point we are ahead of the entire industry because of those decisions. So we are understanding, for instance, the safety bar that we have to meet. We have to fit into the corporate IT infrastructure of our customers. We have to understand what it is they're trying to solve and work with them on a solution together. So we don't just come with the device. We need to come with answers that provide an ROI for our customers. And all of that helps us to enterprise harden our solution versus the others. And it's also created quite a bit of demand, so much so that we are building a factory. We'll be online this summer, just outside of Salem, Oregon. And over time, we will have a capacity of about 10,000 units a year there.
My gosh, I love it. This idea that you went into the customer as early as possible to understand how you've integrated, and you can see that because of your partnerships with Amazon and GXO, right? A very large logistics manufacturer who's introducing you to companies like Spanx. You were there, getting involved, and then you designed the robot as you were thinking about those problems. Melonee, can you explain that specifically about why did you choose, the Digit looks very different, right? The legs and so forth. Why did you design it this way?
Yeah, I think when we look at how we thought about the design for the Digit robot, I think there were a couple of things. Jonathan Hurst, one of the co-founders of the company, was very focused on making sure that the robot had the agileness enough, it was agile enough, to get around the facility and do things that made sense from a motion perspective, from a first principles and physics perspective. And some of that led to some very great side effects. For example, because our knees are backwards, as a lot of people call it, we're able to get very close to the things that we want to manipulate. And we're able to work in more confined spaces, which As someone who spent about a decade working in autonomous mobile robots, there are some really advantages to having a dynamically stable robot like Digit that allows us to reach deeply into these kind of confined situations. For example, here you see Digit reaching into a put wall and pulling a toad out. And it allows us to get a lot closer to conveyor and other things that we have to interact with, or other robots that we have to interact with. A lot of the technology space that you see today has been formed through islands of automation. And so that's the other thing that we've been really purposeful about, is our ability to interact with other types of automation and connect to those types of automation purposefully. So not only from a physical sense of interacting with it, but from a IT infosec sense of being able to connect to the WMS or interact with, say, other fixed automation like conveyor or other robots. I mean, many of the engagements that we have today is Digit interacting with other robots, other autonomous mobile robots, and things like that. And eventually, it will expand to things like you see here, which is
Oh,
us connecting to traditional automation components like grippers and other fixed automation solutions.
gotcha. Sorry, I
Oh, no
jumped out of that
worries.
right when you were talking about that. That's brilliant. So I love the fact that you guys are actually in customers right now. Maybe Peggy, you can explain exactly what it is that you are. What is your partnership with Amazon? What is your partnership with GXO? Which facilities and customers you're physically in now, and what kind of activities you guys are doing?
Yeah, so we're working closely with both of them. Amazon has a number of use cases that we have been working through with them. As you know, they're highly automated already. But as Melonee said, this requires us to work with different points of automation that are already in there and then connecting into the IT infrastructure as well. And so we've been able to come in, go into places where they need humans. It's very hard to get humans for many of these jobs. There's quite a labor gap, something like over 1 million open jobs that just can't be filled in the logistics area alone that humanoid robots can step into. And so those are the areas that we're working on with Amazon. With GXO, you mentioned what we did with them over the holidays. We can, pick up totes from an autonomous mobile robot and walk it across and set it on a conveyor belt. We do tote recycling after the totes have been emptied, tote stacking. And so all of the things that are somewhat repetitive, uh, sometimes dirty jobs, even sometimes a little bit dangerous for humans because things are heavy and you're lifting them over and over again. It makes a lot of sense to put a humanoid robot into. So those are the sorts of use cases we're working on now. This is clearly just the beginning. It's where the need is highest. It's where we've got a solid ROI for the customer. But from here, we'll expand out to many more areas inside these facilities and then beyond into other segments beyond logistics, for instance, areas like transportation and retail.
Okay. So people keep saying that, robots are going to be way in the future. Here, you guys actually
They're here
already
now.
doing the work. That's my quick answer to people. It's like, well, have you seen Digit? Digit's already physically in customers' hands. Tell me more, Peggy, about Manhattan Associates. You partner with them. So my understanding is that they are the software system you guys were referring to, that many logistics, factories, retailers, they have this. And then they're going to integrate your fleet management into their system so that it automatically will be distributed to many customers quickly. Is that what that is? And then
Yeah.
beyond, yeah, go ahead. Yeah.
Well, we're a small company and we have a small sales team. So it makes sense for us to first get to know the ecosystem in these facilities and to partner with them, bring value to them, and they can bring value to us. So it's mutually beneficial. Manhattan's one of those partners. They have over 1,300 customers worldwide. They have the largest warehouse management system software, WMS as it's called. And if we can bring a solution together with them that they can then bring to their customers, we have a channel of distribution through them. So Manhattan's one of many partnerships we are arranging right now. Another one is Zion. They're a system integrator in the same space. So we can kind of ride on the back of their go to market, which helps us get to customers who we might not be able to reach with a small sales team. So this is a way to really supersize our distribution. Manhattan has been a wonderful partner, have already introduced us to several of their end customers, and we're able to bring joint solutions to those folks. So it's working already. It's been a great, just a really great relationship.
Okay. So you're already got customers, you already have these partners, you're integrating to these systems. And then tell me more about RoboFab. So very exciting when
Yeah.
you guys made that announcement. You're pretty well the first, I think, of any bot company that's announced that we actually have a factory that we're going to fund and build to create 10,000 digits per year. So I think the number, it's based in Oregon. Like the number one question people have is, it's great that you're making these prototypes and it's easy to make prototypes. It's hard to scale. And the only company, I think many will agree, that has shown that they have the skill is Tesla. They've got manufacturing facilities, they got gigafactories, they can build these at scale. Other companies like you need to prove that you can make that transition, but at least you've made the announcement. You've got a factory that's going to be built sometime. Is it next year? Tell us more about RoboFab.
Yeah, we're well beyond the announcement stage. We will be making robots starting this summer. We already have the facility up and running. We have our first line up and running. This is Andrea Campbell. She is a rock star in the manufacturing area. She runs our operations there. Has was at Apple making iPads. Was at Ford making F-150. So we have the right talent in place. But it was that signal that we were seeing from our customers who, once they find the use case, say, well, I need a whole lot of these. And we had to be ready for that. It made a lot of sense for us to put it in Oregon, where we have our base of engineers. They're nearby. If there's any issue, they can run back and forth. We're not putting engineers on planes. They just go up the highway to the factory and they can get things settled very, very quickly. So it's been a real asset for us to have that. And this also, by the way, I could circle back to our ARC software platform. As we build these robots, customers are, they start with handfuls and then they deploy more and more. We needed to have the right enterprise software to help them manage that fleet that they have, that they're looking after. It's been a great opportunity for people who used to do those jobs that the robots are stepping into, because now they can become a manager of robots. It gives them more of a digital career than just a physical movement of totes. So it's been super interesting to hear folks' reaction to our platform. And I'd love Melonee to talk a bit more about it. It was her brainchild, and we're grateful that she got that up and running so quickly. And we have the ability now to plug into all the systems that already exist in these facilities.
Okay, good. I've got more questions for you, and Melanie. Go ahead and answer that one, though. The Agility Arc, again, fantastic that a company like yours show that you have software, you have the ability to build the Agility Arc, which is a fleet management tool. Tell us more about that.
Yeah, I think that when we look at it, Agility Arc is beyond a fleet management tool. It's more a cloud automation platform, because we're not just focused on directing digits. We're focused on directing the entire automation ecosystem centered around the solution or the problem that we're trying to solve, or the solution we're trying to put in place. So this means that when we go on site, we actually connect into the WMS, we connect into the conveyor, we connect into digits charge dock, any AMRs that we're working with, so that we can orchestrate all of the different pieces as part of the solution to basically give the customer a complete package, instead of needing to have 10 different groups come together to sort out how they're going to solve the problem. And so we do this by creating standard connectors to organizations like Manhattan. We do this by creating easy to use plug and play interfaces for things like PLC controllers. And we do this by making it easy to help our customers translate the work that they want to do into something that Digit and the other automation in the solution can execute on. And so this means not only do we have the capability to manage the fleet, but orchestrate all of the different components, program those components. We actually have stood up a visual programming language based on a standard library like Blockly, scheduling, uh, all of the other things that you need for doing that. In addition to metrics, performance tracking, and even things like tier one, tier two support. We are using our ARC platform as our single pane of glass for not only fleet management, automation orchestration, but documentation and support for the customer, alerting, all of those other things that are absolutely essential to an enterprise platform. And a lot of this came from my deep experience having done this in the AMR industry. And it's very obvious what the industry needs to have a successful product in the market and deliver the outcomes that customers care about. Because what customers care about at the end of the day is throughput and reliability and uptime. And ARC provides the single pane of glass to make sure that they're getting the value that they care about.
Wonderful. Yeah, great. So you have the software, you're integrated directly into the factories. Let's get to the brains. I guess one of the biggest um, concerns that people will have with companies like yours is, where are you going to get the brains? I think you have a partnership with NVIDIA. And tell me more about, to what extent is Digit able to do autonomous work? How do you train them? The difference between an embodied AI versus the general LLMs out there. Can you speak more to that, Melanie?
Yeah, of course. So when you look at the system that we've created, we look at Digit as having a couple of different levels of, we could call it AI or machine learning, whatever we're going to call it this month, because obviously the branding around AI has evolved quickly. Um, I think that we look at it as kind of physical intelligence, semantic intelligence, and then this collective intelligence, where collective intelligence is kind of what you would expect from a cloud-based system. It's less egocentric and more collective centric. And so when you look at physical intelligence, a lot of the physical intelligence that we've focused on is related to our controls architecture, some of the unique physical attributes of the robot, the structure of the legs, and things like that make it easier for us to build models around the robot. One of the things that's very unique about Digit is it's very easy to train. And when during our work with NVIDIA, we found that it was very easy for them to go from sim to real on our architecture because of some of the inherent physical characteristics of the robot. So that was super exciting for us in terms of leveraging some of the sim to real capabilities that NVIDIA, as part of our partnership, is focused on. When we look at semantic intelligence, this is where all the promises that a lot of people are excited about in terms of large language models, large multimodal models, things like that, foundation models. And I think that one of the things that's super exciting about LLMs, specifically in terms of semantic intelligence for the robots, is we can apply it at many different levels. I think one of the most compelling use cases to start is for translating what our end customers want to do, like the workflow that they want to do. I want the robot to go get an order from a put wall, and then I want it to do a behavior based on the urgency of that order, etc. And right now, I think that we're in this intermediate stage where we're doing some manual curation and some kind of learned curation of those behaviors. But I think overall, what we want to get to is where a person can, in natural language, explain to the robot what they want to do. The big challenge is how the robot constructs those models based on the the unique environment that they're in. A lot of LLMs have been trained for more generic use cases and not highly specialized use cases like the factory or a logistics facility. But I think that that's where the next level of collective intelligence comes in, is because one of the things that we're focused on, not only with the ARC platform around automation, is also around data collection, data capture, and using all of that data that we're gathering from the robots to then train future models into specialized LLMs or expert LLMs or other large systems that can then impact either our physical intelligence or our semantic intelligence of the robot. And so when we look at it, we're working on a lot of different things. We do use um, AI capabilities in some parts of the robot today. But one of the big challenges overarching for humanoids right now are mobile manipulation robots, because Digit is a mobile manipulation robot, is safety. And so one of the challenges with rolling out some of these learning based approaches is figuring out how to layer it in properly with the safety requirements of the industry that we're executing in. And so that's something that we're on a good path on, because we're targeting having full collaborative safety for the robot in the next 2 to 3 years. But I think that that's kind of some of where we're in the journey of how we deploy this technology so that it's safe for the environments we're deploying in.
Yeah. So as a cobot, right, and you guys have your humanoid bots right in the factory working side by side with humans. That's why it's critical. And you will learn that by, putting tests in and studying it. And this is what you're talking about. Love that you can now train the bot with AI. You can speak to it. It can understand you. So Peggy, what is your biggest priority in the next several months? When are you going to clarify again? When are you going to have? How many bots do you have now? How many will you have soon? And what is your targets and what's your big vision for Agility?
So we have tens of bots now. We'll have hundreds of bots next year and thousands the year after. That's kind of the ramp you'll see at our factory. But I think what's next is, because we can deploy, that's actually a big differentiator. Because we can deploy right now, we're not gated by AI to deployment. We do get out in front of all of these things. So we're just bringing all of that intelligence in, and as part of a data lake that we've got sort of a 3-year head start in building of customer data. That's helping us teach Digit new skills. So the big thing that we'll be looking at going forward is taking what we've learned in this more narrower environment of logistics and taking that off to other segments of the economy, and being able to teach Digit new skills much more quickly than sort of the old way, which is engineers sitting down writing algorithms to control Digit. We'll be able to rely on the data lake of all of that interactivity that we've done at customers to teach Digit new skills. So we're excited about that. Another area that we've been focused on is the end effectors, or the hands, if you will. We've got the ability to swap out our hands, and you can think of it as a tool. We can swap in actual tools. We can have a specially built gripper if there's a certain use case at a customer that's requires something different. Turns out you don't necessarily need 5 fingers to do a lot of the tasks that are needed today in these facilities. And there's a lot of complexity to getting all of that working right. And so we're looking at what are the right end effectors that can do the jobs that are needed right now. And then what do we need going forward as we start to branch out into some of these other segments. So that's a real differentiator that we have, that we can actually swap out the end effectors.
I love it. Okay, so you need to learn more about all these different categories. So it's wrong for me to say that Digit is only going to do factories. You guys
That
are.
is definitely wrong.
Sorry,
that's
I've said
where
it
the
so many
need is.
times. Yeah. Okay. I will
Yeah.
change the words I'm using. You guys are moving to
Thank you.
other industries. What other
Yeah.
industries? And I know you already did Spang, so you're going to go retail. What other? What's your next industries?
One of the nearest term industries is the transportation industry. So it turns out that inside of many of the automotive facilities, they have a lot of the same sorts of needs. They're moving a lot of product around, different kinds of product. So that's another use case and focus area for us. Retail is one. We're working with some of the larger grocery chains, looking at helping them during night operations. So there's a lot of very similar type of needs, but in these other vertical segments that we're focusing on, learning about their environments, understanding what it is that they need solved for, and then working with them to come up with that solution.
Okay. And then so I want to know more about the swappable hands. But while I have you here, Peggy, continue asking your question. I mean, so you seem to have each of the steps required, right? You get your customers, you got your partners, you got the cat factory. What's your fundraising? How much money have you raised? How much money do you think you'll need to raise? What's your steps there?
Yeah, so we closed a Series B uh, almost 2 years ago now, where we had raised 150 million. We have runway ahead of us. We will start to raise again at some point. The good thing is we're able to deploy robots, and so there's revenue that goes with that, and we're that'll become part of the equation, if you will. We actually have two business models. One is a CapEx plus SaaS business model, you can think of it, where the customer buys the robot upfront and there's an ongoing SaaS fee that, for instance, for use of the ARC platform. We also have a robots as a service business model where the customer, it's a lower bar for them, and the customer can pay as they go on a monthly basis. It includes the ARC software, includes maintenance. We bring them a working robot and we do the work. And it helps for more mid-sized customers to bring the cost down, the initial cost down. It allows them to do some experimentation before they jump in with a larger fleet. And both of those have been very, very well received. And we have activity going in both of those areas. In fact, we'll have some announcements here in the next few weeks. So stay tuned on that.
Okay. And how much in ballpark, how much are you charging customers on the SaaS model, for example?
We haven't disclosed that publicly, but what we can say is that we're generally on par with a human laborer. And so if we can, that's what our customers are looking for. If we can come in at that level, they will proceed. And so that's what we've been looking at doing. If on the CapEx model, we're just under 2 years in an ROI on the CapEx model.
Gotcha. Okay. Let me bring in Dr. Scott Walter to the conversation. He is a two-time robotics company founder. He and I have been interviewing quite a number of the humanoid bot executives and CEOs. And then, we need to find out more about your battery life and your hands and so forth. So Scott, welcome.
Hello, Melanie. It's a pleasure to be here. Boy, I have all sorts of questions from listening in. And I think the first thing I want to do is address sort of what Peggy was talking about, because it's come up a few times that the first time I saw Digit was when it was at a trade show a little over a year ago. And it was like the first time a humanoid bot was really shown doing real work publicly. And then you did it again, and you're still like the only one to really do it. Others have maybe unveiled the bot or something like that, but not really shown it doing anything good. And Herbert also mentioned the term useful work earlier. And a lot of people mention that term. And what does useful work really mean? And I decided to sort of define it one time as pretty much being able to do the same task that a human is already currently doing, be able to do it with the same reliability, the same repeatability, accuracy, cycle time, for the same kind of duration, and then most importantly, for the same cost. So Peggy, you've talked about the ROI as being there, as being equivalent to the human labor, because you almost asked the question I had. So it sounds like you really are doing useful work. And the first example, of course, was GXO with the spandex. So it's like, okay, it was doing real work. We can agree with that. It's doing real work. Something was getting done. The question was it to the level that it was useful in that they could say, yes, it makes sense to actually purchase or to use a humanoid bot to do this.
Yeah, and that's exactly where we were at with them over the holidays. They needed more labor, and obviously things get peaky at the holidays and you need to fill in with humans. They have the same issue as everybody else in the logistics arena does. We can't get enough humans to take these jobs. And so they agreed to allow us to come in and actually take shifts during the holiday season. That worked out very well for them. We continue to have conversations with them, but that's the sort of thing that we're focused on. What can we do that delivers you value right now? And that's why we're focused on those areas. We're not as focused on making coffee or doing backflips. We're focused on doing real work. That's where the problem is. That's what we're trying to solve.
Yeah, so that's what it sounds like. So they were able to afford it when they were sort of in that peak labor demand area. Can they still afford it, let's say, in the off season when, okay, so I'm seeing Melonee now. So basically you really are doing useful work, and that anyone that has a solution, or let's say has a problem right now, they should be seriously considering using a humanoid bot to do it. Now, the other question I have here for Melonee is that you come from the AMR world. So you know all about robots with wheels. So the obvious question is, wait a minute, why legs? Why not wheels?
Yeah, yeah. Everyone asks me that after spending most of a decade working on AMRs. Why did you suddenly lose faith and go to legs? And it's not that I lost faith. It's that I found over the last 10 years that AMRs are very good at specific types of problems. And there are serious limitations to AMRs when you start trying to do more complex tasks. Um, a lot of those limitations come around stability. So much of AMR's success relies around being able to be in relatively tight spaces with people and navigate around them and get to endpoints and deliver goods or be loaded by people with goods. That's a very common use case. But when you start trying to put appliances on AMRs to reach into shelving and to grab things, AMRs become pretty tippy because many of them don't have really great low center of gravity. And in order to get that better center of gravity, to lower it to the ground, things like that, you have to either make the footprint a lot bigger. And in the warehouse, space is king. Every square foot that you take up, you're spending thousands of dollars from an operator perspective. And so they don't want to make the aisles wider and things like that. And so when you start trying to lift a 16 kilogram tote 1 meter out from a tiny AMR, it falls over. And so there's lots of situations in the warehouse where customers really just want to move material from shelving units to other locations. And there aren't great solutions for wheeled mobile robots that are not dynamically stable to grab these very heavy totes at long distances in deep recessed shelving and bring them to different locations. And so, a lot of what I saw with the mobile manipulation space, specifically bipedal dynamically stable robots, is it solves many of those problems. Obviously, there's new problems that come along with that. Like I said, safety, but I have a deep background in safety. I looked at Digit. There's some very particular things about the robot that make it a great candidate for collaborative safety and being a breaking robot in that sense. And so I was excited to join Agility and help them commercialize the technology because I really saw it as the next stage of opportunity for autonomous mobile robots in facilities. And what's even funnier is many of the applications that we're getting deployed in today, Digit is the AMR's best friend, and to me it's very satisfying because I spent such a long time in the AMR market, and to see the next robot that I'm working on being a buddy to the last robot I worked on is super exciting.
Yeah, I kind of agree that the AMR makes sense when you have sort of the medium haul to long haul kind of movement from one side of the factory to another. You wouldn't even have a human doing that. So, but when you get to the end, it's people talk about the last mile problem. It's literally like the last foot problem in that case. And either, yeah, you stick an arm on there, which you're having going back and forth all the time. That's not really being used except at the endpoints, or like just put the robots at the endpoints, and not only just sticking a robot, but a deployable robot. So when it's not needed at that endpoint right now, it can do something else and come back to it. So that sort of does make sense. Now, you talked a little bit earlier about ARC, and so I've got a question for that and the integration you have there. So typically, like in a lot of packaging situations, you might have like a pick to light, where the human is just going up there and looking exactly what they're supposed to do. Now, is Digit able? Does it do pick to light, or does it not need that because it's actually tied into the system and it knows what to do next?
Yeah, I wouldn't need to do pick to light, because basically what pick to light is doing is it's saying light up slot A. And so it knows that you have to go to slot A. And so it just transmits slot A directly to Digit. And so it actually, pick to light is like the Digit's best friend in some ways, because the packet, that's transmitted from the WMS is perfectly formed for transmitting it to a robot. And so that's one of the really great things about all of the infrastructure that's been built for humans, whether it's voice, text, it's voice, pick to voice, or pick to light, or pick to X. Many of those systems are well architected for being transformed to basically direct robots just as well as it directs people. So that's super awesome in general.
Okay, yeah. Well, Peggy, I've got a question for you now. Is I noticed that the last thing you did before you joined Agility was that you ran the Tokyo Marathon.
Oh,
So are you looking forward to someday running a marathon with Digit?
I did. I've talked about this. I think Digit would beat me probably. The predecessor, Cassie, was that Jonathan Hurst, our founder, worked on at Oregon State. Is a very fast runner, and I am not a very fast runner. So I don't know that I can win any race with Digit in
But
it.
but
Scott,
still, it's an endurance event. That 26 miles is pretty long. It probably have to start with like a 5K and then maybe a 10K or something like that.
Yeah, maybe somewhere in there. Digit
uh,
has a battery, and I don't.
Scott, I thought you were going to refer to her work at Magic Leap and maybe Microsoft. I mean, like the Magic Leap thing. I mean, there's, we're talking about virtual environments.
Yeah, yeah. I
Please
mean,
ask
there's probably
questions
a
about
tie-in
that.
there.
Go
Yeah,
ahead.
there could be a tie-in
Okay,
there
go.
because certainly telerobotic operations and stuff like that is there a role kind of for the Magic Leap as being a part of that or using a technology similar to that?
Definitely, there's similarities in technologies with things like computer vision and perception. They were very deep on that in the Magic Leap headset. So there's a lot of crossover in those sorts of technologies as Digit learns to understand its environment and move to the right box or location to do its next task. There's actually quite a bit of synergy there.
Yeah. And then I have like some questions I always ask, like asking about the kinematics of the bot. And I noticed that there's been a little bit of an evolution to the arms that you are using in Digit, and that in the first case you had like a 4-axis arm, and the shoulder was designed a particular way. And then when you went to the 7-axis, I assumed the shoulder was the same, and you completely changed it. And it actually was a bit disappointed because I love that shoulder design. And so, Melonee, can you talk to me about that and why you decided to go what I guess you'd say more traditionally off-pitch roll kind of shoulder versus what you had before?
Yeah, I think a lot of it had to do with the tasks that we wanted to take on and the manipulation workspace that we wanted to achieve, right? Like when you look at the manipulation workspace that we want to work in long term, it requires us to be able to get into tight spaces, reach into things, and that requires us to have more of a 313 kind of manipulation joint space architecture, which gives us more complete volumetric workspace where we can get to any point in space with a lot of flexibility, right? So that if we wanted to do, say, machine tending down the road, which is definitely one of the things that we're looking at, that requires us to reach into a enclosed space like a CNC machine. And so we have to be able to reach around corners. And you even see that now with say like fixed shelving. If the shelving is near a wall, we need to be able to either have our elbow really down when grabbing or really up when grabbing so that we're not colliding with the wall. And so that's kind of more what's driving us towards that architecture, not any particular bias for the aesthetic of the robot, or our particular predilection with some joint configuration. It's really about the brass tacks of practical robotics, let's call it.
So you said that you have tens of robots now, hundreds and then thousands in the future. When will you feel like you're design locked?
Hmm. So a lot of our design lock is driving towards full collaborative safety. That's when I think we'll call design lock. So right now, we right now deploy in work cells as part of our safety strategy, because the most of the prevailing standards are relatively silent on dynamically stable humanoids. So the prevailing standard is ANSI RA R1508, which basically governs AMRs and mobile manipulation robots. And the standard is a little bit silent on what happens when dynamically stable robots fall due to tripping or power loss. And so we're still working through that. But we believe that we will have a fully collaborative robot, like I said, in the next 2 to 3 years. And when we achieve that, that's when I think I will have the confidence to say that we are completely design locked.
That's why I love that you guys. I thought that that's why you designed the bot to be very fairly thin, very short. It's
Yeah.
part of the whole thing, right? It's more cost effective for you to scale, but also it's going to be safer when it's
Yes.
near humans, correct? And so
Yeah.
it feels like you've already been thinking about this. But maybe, I mean, I don't know. I'm speaking out of turn here, but when I look at the legs, could that somehow trap somebody's arms? And if I
Mm.
put my arm there, could it hurt me?
Yeah. So the thing is that when you look at safety, it would you'd have to look at it from a risk assessment point of view, and what you're talking about would be almost considered misuse. Like someone would have to dive and throw their arm into the legs when the robot is collapsing. But we are looking at ways to make that avoidable, because safety is a composition of three things: one severity, two, avoidability, and three, frequency of exposure. And so when you look at, well, how often would you be exposed to the legs collapsing like that? To how avoidable is it for you to not have your arm or your head in that space? And three, what is the severity of that action? Um, we think that there's a way to design the behavior of the robot such that that wouldn't be a severe uh, injury, and also it would be highly avoidable, and the frequency of exposure would be low.
Mhm. And then the interchangeable hands, I guess we need to ask that because that's very unique. That's a different approach than some of the humanoid bots who are going for the 22 degrees of freedom of they have the fingers. You guys said, are you guys going to actually do that? You will head there, but right now you're looking at different form factors.
Yeah, so I think that the interchangeable hands doesn't preclude a five-fingered hand. It just means that we can put many types of hands on the robot. And when you look at the last 60 years of industrial robotic arms, I think we've proven that we don't need five-fingered hands to do most of the tasks that exist in logistics and manufacturing. And why would we turn our back on all of that? So that's one. Two, when you look at like automotive scenarios or other high throughput production scenarios, typically humans are holding things like screw guns that are auto fed. So, or a rivet gun that's auto fed. And so, like, rivets just go to the tip of the gun and they put it in. And when you contemplate five fingered hands, there's a couple of questions you may have there. Like, is Digit going to use that? Why wouldn't you just put that on Digit's hand or on its end of arm tooling? And if it's not going to use that, then are you really contemplating fiddling through a screw bin to grab a screw to put at the end of a screwdriver or screw gun? I mean, it actually, I feel like in some ways five fingered hands is almost a backward step in some realities, because of some of the ways that we look at tools, tooling, and the way people use tools today. we've built highly specialized tools for humans to use. And it seems odd that we wouldn't use the same highly specialized tools, but with a robotic interface. And that would free us from like dangling cords and all sorts of other things because it could be self-powered by the robot, which would be, I think, more advantageous than building fiddly five-fingered hands that are hard to control, technically not as robust right now, and lead to more problems than they're worth when we have 60 years of industrial robotic technology that is robust, works well, and solves the problem.
Yeah, I think another common question everyone has comes down to the actuators and servos. And I assume you found that you had to design your own. Is that the case? And are you considering manufacturing your own servos, or you kind of have a supplier for that?
Yeah. So we do have a mixture of different actuators in the robot. They are a mixture of cycloidal technologies or harmonic drive technologies. The actuators are custom designed. Some of them we are using a contract manufacturer to manufacture. Some of them we're manufacturing in house. Um, but we are driving more and more towards the cycloidal technology because it gives us high transparency in the robotic arm and legs that allow us to have better sensing of what the robot's doing and better control for doing the different types of activities that we want to do. But honestly, I think that in general, we're going to use whatever the best technology is at the right price for solving these problems because really what we're trying to do is solve the problem for the customer and hit the price point they care about, or I should say more accurately, the return on investment that they care about.
Yeah, and in that case, when you're talking about sort of the price point of the robot, when I try to do the bill of materials, it seems like it's the actuators. When you start adding that up, that is like 50% or more, maybe depending upon the assumptions you make and how much it costs to be able to produce just one particular servo. Is that a proper assumption, and is that what you're trying to drive the cost structure down on, or are there other items in there that are costly?
Yeah, I think that the actually typically the most costly things inside of the robot are sensors and safety. Um, Largely because right now safety systems there isn't much competition in that market, and so they have a premium on them, and it's actually you understand why there's a premium because it takes so long to safety certify and bring that technology to market. But I believe that there's a path with actuators because eventually actuators drive towards bare metal costs. Um, I think that where you see the sticking points are around sensors, you see the sticking points around safety, and you eventually get to the bare metal costs that end up being your big problem, especially when you look at like the large volume end state when you're building tens of thousands of robots. And I think that Amazon is a good example of a company that you could look at to see where the price trajectory goes because they're one of the few companies in the world who have built almost a million robots, or KUKA, or one of those large industrial arms suppliers where I think when they first started, let's say like a KUKA or a FANUC, when they first started, the robotic arms cost hundreds of thousands of dollars, and now they're in the sub 50,000, even into low 20s of thousands of cost. But I think they're getting down into the bare metal cost problem where you can't get past the cost of aluminum per weight. You can't get past the cost of steel per weight overall.
Is the is the rate limiting step today is the biggest challenge the AI part of it, the training and the ability to understand, or is it the manufacturing of the robot at this point at scale?
I actually think that having built a robotics company that did all of this stuff, but just with wheels, um, the rate limiting actually becomes the deployment. If you look even historically across all other robotic companies like a Kiva or a FANUC or a KUKA, The thing that ends up limiting you is typically not the robotics technology, typically not the factory. It's your ability to service customers and deploy rapidly. And so that's why with ARC, we're highly focused on making our deployment time very short. So right now, when you look at our customer deployments, they take about a week and a half to get on site and deploy and get the system up and running. We're targeting doing it in less than 72 hours long term so that we can make sure that we're getting the robots deployed and on site, because you can just see it time and time again. You look at AutoStore, you look at Symbotic, you look at Kiva, all of those systems and all of the large like industrial kind of automation systems take months, not days, not weeks. And really the key to unlocking to be able to deploy robots massively at scale is getting the deployment time to be very short.
So how close are you guys? Because I loved it when you brought in the big guns, Peggy Johnson. You brought her in because strategic partnerships, sales. You guys are ready to go and scaling. Can you tell me more about that, Peggy? What is it that you're going to be doing the next several months here?
Yeah, so these initial deployments are all with companies. We've actually worked very hard to just focus on companies who have a deployment plan, and so we're trying to stay out of the innovation areas of some of the companies because you can get caught in a loop there. So it's like they have a problem, we solve the problem, they can deploy more broadly. So that's, as I said, you'll see a few announcements coming up. These are companies that have a plan to deploy broadly, which will drive that volume, which is why we built the factory. The factory is CapEx light. It's somewhat automated. It's largely assembly and test and repair that we can do there, but it does mean we can also build another one if needed. We've already got the plans for this one, and so we can replicate and scale very, very quickly as our customers need it. And we've kept an eye on that since the start here because we don't want to get caught in the loop where we've satisfied the customer, we've solved the problem, and we can't deliver. We have to be able to scale, and we have to be able to uh, tell that to the customer on day one. If you want to deploy, we're going to be there to help you get units out.
Mm-hmm.
And Peggy, do you think someday Digit will be building Digit?
It can, yeah. We've already got some plans for it to help in our receiving area. So we're
Yeah, so
we're
I assume
starting
there's
right
already
there. Oh yeah.
there's already a little bit of value add. And of course, the question is when you finally get to 100%. So you're doing like 1-2% right now, but eventually you think you'll get to 100%? Because there's gonna be a lot of
Eventually,
machining on there, right? And then right now, like the loading and offloading of the machines, as Melanie pointed out, is something that's usually a human operation. It can be automated within typical industrial robots, but again, that's something you could probably have Digit be playing a role in.
over the long term, that's exactly where we'd like to go. The end effectors and being able to swap those out is going to be a big piece of that puzzle of getting to that end game. So we're fully excited about that.
Mm.
Yeah, and I think, Scott, it depends on how you view what it means to build a digit. Because right now, if you look at the RoboFab, it's largely assembly and test. We use third-party fabricators to obviously bend the metal and machine the metal, right? So all of the subcomponents come in-house, and then we assemble it.
Yeah, that means you've got all your suppliers. You could start selling Digit to them to do whatever it is that they're doing in those areas as well.
Interesting. So, Peggy, tell me more about how you view your competitors. Who's going to succeed? Who won't? And what will it take for your company to succeed, to survive? How much money will you need? I mean, people are saying this is capital intensive to build, once you get past 10,000 robots, what's your ambitions? 1 million? How much will you need to do? Is it a race? I think you're on mute.
There we go. It is a race, and we're ahead in that race right now. And we aim to stay ahead in that race. We have the expertise, we have the knowledge of these environments, we have the understanding of what it takes to meet the safety bars of our customers. And so we intend to keep innovating. We have lots more to go to stay ahead. Once we get to collaborative safety, that'll open up all sorts of new markets and eventually moving out and into the consumer market. So that is our vision. That's our plan. And, we have every intention of meeting that goal. Um, we have, I would say for a small team, this team has really punched above its weight. They've got, robots that are working, and customers have ascribed a value to it, and that is quite a milestone. And we're bringing revenue in. We have some of our first contracts that'll be announced here, revenue producing contracts, and that'll just start the flywheel of an actual business, which is where we're focused.
So is it fair to say that the market is so big, the opportunity is pretty big that, who's going to survive? Like which companies, or let's put it this way, who will die and why will they die? The other competitors who are trying to do this.
It's interesting. We've obviously thought a lot about that internally. I think it's a mistake to not think about the physics of the robot, the actual physical intelligence of the robot as paramount, and then AI layered on top of that. Because starting with AI, trying to control a robot simply with AI algorithms right now seems too early in the state that AI is in right now. We use it as an effective aid to what we're doing, but it is not the thing that we rely on to deploy these robots. So I think any of the companies in the space that are hoping for AI to be the answer to supercharge things may be missing the fact that the physical intelligence of these robots is paramount. That has to be solved along with the semantic intelligence. And I think to miss that could endanger some of our competitors.
But do you guys agree with some people who say that you need 1,000 robots or more out there in the physical real world, take that data, take that AI, and that's how you really truly train, the bots to move and the bots to think and make actions?
Go ahead. Yeah. We talk a lot about this internally. Go ahead, Melonee.
It's complicated.
Yeah.
I think as someone who built something like this in my past life, yes and no. I think that you can do certain types of training without large data, but I think the more complex and interesting things happen when you get to fleet sizes that are 6, 7, 800 robots. We definitely were there in my last company, and we definitely did a lot of interesting machine learning AI things using the data that we had. We had a very, very large data lake. The robots generated 30 gigs a day. And so we're going to build something just as comprehensive at Agility. And the thing is Digit generates a heck of a lot more data than AMRs. I think 3 to 5 times more data than AMRs daily. So, but I think it's somewhere in between. I think that 1,000 robots is, I think, a pretty big statement, and it depends on what problem you're trying to solve. If you're trying to solve a problem for a specific customer, you may just need enough facilities that you're seeing, maybe not enough many robots, right? It just depends on what the problem is, why you need the data, what you need the data for, and we're going to be very pragmatic about figuring that out. But the good thing is we will have the data lake and the data lake house as the new terminology is coming out around, different data lake storage methodologies and things like that.
Okay. Scott, do you want to ask one of your favorite questions you haven't asked yet?
Yeah. Here we go. So it's basically it's 2 questions in one. So the first question is, Melonee, and maybe even Peggy, if you want to take a stab at this. I have a magic actuator that costs you absolutely no money, no mass penalty, and doesn't take up any power. So that means you can add one more joint anywhere to Digit. Where would you add it?
Probably in the waist of the robot.
Okay.
Wait, does it have a neck?
It does, but moving the head is not as interesting as moving the arms. Remember, as As someone, I was watching a talk by Sanctuary the other day, and I thought they
Yeah.
had an apropos way of putting this. It's like the purpose of your robot is to move the hands through space,
Yeah.
Yeah.
and
That
I thought
that
that
was
was
my interview.
really,
That was my
yeah,
interview.
I
Yeah.
thought
Yeah. Yeah. Yeah.
that was very clever way of putting it. And so if I was going to put an actuator in the robot, it would definitely be centered around giving the hands a new degree of freedom in some sense. Although the head could be compelling in some ways, I think Boston Dynamics has demonstrated, a really good point with their stretch robot, where they use that uh, joint to basically move their camera system back and forth very rapidly. Um, I think that there's a lot of advantages to being able to have a waist joint that allows you to move like that.
Yeah. Now, which waist joint? Are you talking about just being able to turn or to lean forward?
No, to turn.
Okay. So
Yeah,
yeah, about the
our
vertical
leg
axis.
architecture gives us a lot of advantage in squatting, so we're
Hmm.
not going to be needing to bend as much. A
Yeah.
lot of our limitation is in turning, and that's just because of the way Digit's designed. We can squat very very low to the ground, and
Hmm.
that's a huge advantage that we have in the environments that we work in.
Okay. So now I'm going to turn it around. Peggy comes to you and says that there's no way we can get the cost of digit down below a certain level unless we throw out one joint. Which one is it?
Ooh, controversy.
Yes.
A fight within the departments.
It might be
Yeah.
from within.
It's probably going to be an ankle joint.
Okay. So yeah, because you get two joints down there
Yeah.
that are kind of useful. Yeah. I mean, it's a tough call, isn't
It's
it? I
a
mean,
really tough call, but it would probably be an ankle or it might be a hip joint. It depends, but
the
it would
hip
be
joints
one
are
of the joints in the
tricky.
leg most likely because I need all the
Yeah.
joints in the arm, and we
Yeah.
don't have a
And
neck joint, so
yeah, you don't have a neck joint.
yeah,
If you throw one out of the hip, it's going to even be tougher to be able to turn.
yeah, yeah.
And that ankle joint is almost for unlevel surfaces. But then again, I've seen where Digit has been walking. You need those ankle joints.
Well,
Going up those hills, it definitely does.
but remember the right now our initial markets. You're speaking to a product person, right? Like and an
Hmm.
engineer, and so like my point of view on this is if the goal is to get to a price point that the customer cares about and they only have flat floors, ankle joints might go. And that's a short term problem, right? We can always, when we want to go into a new market that needs ankle joints, we put them back in and we unlock that capability. It's not like we can't, put things back in after we take them out.
Yeah. Now this is really interesting because you have a 7 degree of freedom arm, which basically means that you have one more joint in your arm than you really need, but you have it there, like you say, for that elbow
Yeah.
redundancy. So in some places, that would almost be one place you could say, we can take it out of there. You could maybe take it out of the shoulder, or maybe you could say, I don't need my hand to do this. I could throw one out there. But you didn't go for that.
No, absolutely
You
not.
didn't go for my bait there. So that
Yeah.
shows that you see the importance, like you said, manipulating the hand through space to getting
Yeah.
it to where it needs to be. Okay.
Remember, I spent 7 years working on the PR2. I was at Willow Garage for a long time, spent a lot of time working on mobile manipulation and thinking about these manipulation problems long before even mobile manipulation robots were a thing. So, have a long history of thinking about these problems.
Good, good. See, that's why I like asking that question is because we get to find a little bit about how your mind works.
Yeah.
So thank you both, Peggy and Melanie. This was very refreshing. Really enjoyed you guys. You guys are very different than many other companies. You approach the humanoid form differently than others. You have a different perspective in terms of the hands and interchangeable. You have a different, you've made major partnerships. You've been in the factory as soon as in the workspace as soon as you could have, and then you've got your factory being built already or being planned. And then I noticed here that Peggy, you are named as one of the most powerful female engineers in the US, being inducted into the Women in Technology Hall of Fame. So it's like you both are both. And then Melanie is actually one of the 8 CEOs changing the way the world works. Like you guys have the right team and your women led team, regardless, you have the right people in place. So Thank you very much, both of you. Appreciate your time.
Thanks again for having us.
Thank you. It was a pleasure.
Good.
Yeah,
Thank you.
thank you.
I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.